All right, guys, we're finishing up. These are definitely the more difficult problems in the packet. On our quiz, we will have some of the easier right triangle trig problems, and we will have a couple of these where you've got cars on either side of a plane or something like that. So first, check your calculator. Mine's in radian mode. It needs to be in degree. So I'm going to press mode, enter degree. I will remind you about this on quiz day as well. Okay, so first we need a picture. So this 56 says an airplane is flying at an elevation of 5,150 feet directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane. What does that mean so far? So here's a plane up in the air. We know that its elevation is 5,150. So the plane's up here above a straight highway. And there's one car over here, and there's one car over here. So on opposite sides of the plane just means they are on opposite sides of the plane, like as far as whether the plane is to their right or to their left. And then we have angles of depression. An angle of depression to one car is 35 degrees. The other is 52. Remember, an angle of depression is not this angle at the top of the triangle. It's if you were looking down, you would be looking down 35 degrees. And what you should really do with that information is just put your angle of depression as an angle of elevation. They're always equal to each other because they are alternate interior angles. So we talked about that in our notes. So same thing for this one. Now, I didn't really draw anything to scale. So my car that has a smaller angle of depression should be farther out. Like you don't have to tilt your head as far to see how far out that car is. This one you have to look down farther because it's closer to you. I'm not worried about scale so much, but just sort of FYI. How far apart are the cars? So what is this distance between the two cars? Well, we have two right triangles. So if we could find this leg of this right triangle and this leg of this right triangle, we could just add them together and the total distance would be x plus y. So that's what we're going to do. We have an angle, we have an opposite, and an adjacent. And that's true in both triangles. Oh, this one is 52. So start with the first triangle. It doesn't really matter which one you start with, but I'm going to say tangent of 35 degrees would have to equal 5,150 divided by x. And then in the other triangle, the tangent of 52 degrees would equal 5,150 divided by y. And we need to solve for x and y in both equations. So in both cases, you need to multiply the denominator, the variable out of the denominator. So x tangent of 35 equals 5,150. And then I will divide by the tangent of 35. And that's what I'm going to put in my calculator for x. And same steps to solve for y. So multiply y over to this side. Y times the tangent of 52 equals 5,150. And then divide by the tangent of 52. Remember that anytime we're using a calculator to combine answers, you don't want to round anything. So I need to find x plus y. So I'm just going to do that by typing in this expression plus this expression. So, and remember too, we've talked about this before, but there we go. But you can type in fractions in your calculator. So you can do like alpha y equals, and that pulls up this little fraction thing. So it doesn't really matter for this one. I don't have a ton of parentheses, but I don't know, kind of nice, especially if there's addition or subtraction happening in your fraction. It's kind of nice to use this. So this is x, and I'm adding to that y. And now this is the answer I can round to three places. So I'm getting 11,378.583. And this is measured in feet because the 5,180 was measured in feet. So that's our total distance between the two cars. All right, now problem 57 is using the same plane. If both cars in the previous exercise are on one side of the plane, And the angle of depression is now 38 and the other one is still 52. How far apart are the cars? So I don't know why they changed one of the angles of depression by 3 degrees, but let's draw this triangle first. So now say the plane is here and one car is over here. The other car is still on the same side of the highway, but it's further out. Now here, your angle placement matters because the angles of, I know this says depression, but remember, you can draw these as angles of elevation as well. So the angle of elevation that's higher has to be the one that's closer to the plane, because if you're closer, you're going to have to look up higher to see the plane. And so the 38 has to go out here. Okay, and then be careful because the two distances, we need legs of right triangles. So I know the plane height is 5,150. How far apart of the cars are asking you to find this distance here? Like, what is this section? But that little section is not the leg of a right triangle. Excuse me. So what you really have here is, here's a right triangle where, let me put this on the inside, where I've got just this small one here, 52-degree angle, right? I've got that. And then the other right triangle is like this big one here. We've got this big outer right triangle where the angle we're using is 38 degrees. Still have a side opposite that's 5,150. But this big side, I'm going to call that y. And once I have y and I have x, if I subtract y and x, the large number minus the small one, that would tell me how far apart they are. All right, so let's set this up. So I'm just going to start with x. So the tangent of 52 degrees is equal to 5,150 divided by x. And I can go ahead and solve that for x. So multiply x over to the left side, and now divide by the tangent of 52. So we have x. I'm not going to type that in yet. And then I need to find y. So y is going to be the tangent of 38 degrees is equal to 5,150 divided by y. And we solve for y the same way. Multiply y over to get it out of the denominator. And then divide by, this time divide by the tangent of 38. And like I said, the distance between those two cars now is going to be y minus x. So when I type this in, I'm going to type in y first. So alpha y equals, so 5,150 divided by the tangent of 38 minus 5,150 over the tangent of 52. So these cars are 2,568.078, and that's still measured in feet because we're using the same units as we did last problem. All right. Number 58. A hot air balloon is floating above a straight road, so this sounds familiar. To estimate their height above the ground, the balloonists simultaneously measure the angle of depression to two consecutive mileposts. Mileposts are posts that are exactly a mile apart on the same side of the balloon. So same side. So kind of the picture we just drew. They gave us angles of depression. How high is the balloon? So let's draw the same. We've got two mileposts on the same side of a balloon. So same picture as the previous one. So let's just set up the kind of generic triangle for that. Now here's something that's different. This time it's not how far apart are the two cars or how far apart are the two mileposts. We actually know if this is a milepost and this is a milepost, then they are 1 mile apart. So I know this little section. I also know the angles of elevation. Remember, the smaller angle of elevation has to be the one that's further out, and the larger angle of elevation, you're looking up a little bit higher to see the top of whatever you're looking at. So we have that. We don't have their horizontal distances. We don't have the height either. So let's call the height y. The height of the balloon is y. And I don't know the short leg of this, or this leg, excuse me, of the smaller triangle. So I'm going to call that x. So far, there's not a ton to go off of. It's like, okay, tangent of 22 is y over x. I have that. Let's take a look at the bigger triangle. So remember, there's a large triangle out here, this one, where 20 degrees is the angle. Now, what is the leg of that? 1 mile plus x. I would call that x plus 1. Okay, so we could set up a tangent equation with that. That's the tangent of 20 degrees is equal to opposite over adjacent, y over x plus 1. And then let's do what we've been doing in these last few problems. So we've been multiplying the variables out of the denominator. So go ahead and do that. You get x, keep this color coded, sorry. You get x times tangent of 22 degrees equals y. And on this one, when you multiply by x plus 1 to get it over here, it's a good idea to distribute the tangent of 20. We did this with logs a lot, right? If I multiplied an expression times log of 20 or something, I would distribute it through. So let's make it look like that. X tangent of 20 plus 1 times tangent of 20. And that would equal y. Now, both of these equations are equal to y. So we can set the two equations equal to each other. So we can say x times the tangent of 22 degrees has to equal x times the tangent of 20 degrees plus the tangent of 20 degrees. And again, this is similar to work to what we did with logarithms, where if we have to solve for x and x is in a couple of different terms, get your x terms on one side and your non-x terms on the other. So let's subtract this x term to the left side. So x tangent of 22 degrees minus x tangent of 20 degrees is now equal to tangent of 20 degrees. We get our x's on the same side, so we can factor an x out. All right, I'm done color coding, by the way. So that's going to leave me tangent 22 minus tangent 20. And the purpose of factoring the x out is so that we can divide the parentheses to the other side. So x is equal to the tangent of 20 divided by the tangent of 22 minus the tangent of 20. Now, what is that approximate answer? So here's a good one for a good candidate for our fraction bar here. Alpha y equals, gives you the fraction. And then, so this is tangent 20 over tangent of 22, close parentheses to stop that tangent function, and then minus tangent of 20. Now, do not round this. So write down on my paper. I guess I don't have to write it down on my paper, but I'm going to. I'm going to write down the whole thing. Leave it on your calculator screen. That's the important part. And why am I not rounding this? Because this is not my final answer. Read the question again. The question was, how high is the balloon? So what am I looking for? I don't care about x. That's not the balloon height. I really want to find y. So now that I have x, I need to go back and say, well, what is y equal to? So remember, back here, you had a couple of equations for what y is equal to. I would pick the shorter one and say y is equal to x times the tangent of 22. So I'm going to use my non-rounded value for x, because if we use a rounded answer, it's going to throw our answer off by a little bit. We wouldn't get credit on our AP test. And then I'm going to multiply that by the tangent of 22. And here's the nice thing. It's on your screen. You didn't hit clear, so you just, oops, you don't hit divided by. You hit, delete, you hit times tangent of 22. Oh my gosh, I'm hitting all kinds of weird things. Hold on. If you messed up like I did, recalculate that and then hit times tangent of 22. There we go. So this is the answer for y, and this is the one I will round because it's my final answer. So 3.671. So y is approximately 3.671. Now this is measured in miles because the only distance we had was 1 mile. So that's our answer for, what is this? The height of the hot air balloon. Okay, now there is another way to solve this, by the way. If you would have solved these equations for x instead of y, then when you did solve for y, you would get to this answer as well. If you're curious about that, let me know. I can show you in office hours. Okay, number 59, the height of a mountain. So to estimate the height of a mountain above a level plain, an angle of elevation to the top of the mountain is measured to be 32 degrees. So let's just give ourselves a nice spacious, you want to draw large right triangles so you have room to label and like add things to it. Angle of elevation is always at the ground to the top. 1,000 feet closer to the mountain, it's found that the angle of elevation is 35 degrees. So here you are here, get closer to the mountain and look up again. How much closer did you get? You just traveled 1,000 feet. So that's just this little segment here. And now the angle of elevation is 35 degrees. Estimate the height of the mountain. So let's call that y again. This is the same thing we just did. Let's call that y. Let's call this x. See how this is the exact same thing? I just changed numbers. Okay, so let's set it up again. First we had a small triangle where the tangent of 35 degrees was equal to y over x. And then the other triangle is the large triangle where the tangent of 32 degrees is equal to y over x plus 1,000. This whole leg is x plus 1,000. Then what did we do? We solved for y. So multiply the x out of the denominator. When you do that on this side, you're multiplying with parentheses, x plus 1,000. So I'm going to distribute. So x times the tangent of 32 degrees plus 1,000 times the tangent of 32 degrees is equal to y. All right, and then if both of these equations are equal to y, we can set them equal to each other. So x tangent of 35 is equal to x tangent of 32 plus 1,000 tangent of 32. Get your x's on the same side, so x tangent of 35 minus x tangent of 32, so I just moved this over, is equal to, keep a non-x on the other side, 1,000 tangent of 32. All right, and then factor your x out. So x times tangent of 35 minus tangent of 32 is equal to 1,000 tangent of 32. And then divide. So I'm hoping you're seeing that these steps are the exact same for these two problems. So you can kind of, if you go back and rework 58 and 59 a time or two, then you'll have a pretty good muscle memory for other problems like this. So we are likely to have a problem where either two things are on the same side of something or they're on opposite sides like that one. But take a look at this. We've had 3 of these in a row now. Same side, same side, same side. Anyway, this is a value I'm going to get on my calculator. And then y is equal to, remember back here, y is the height that I want. Find the height of the mountain. So y is equal to x times the tangent of 35 degrees. Okay, so let me split screen here and get all of this typed in. So first I need x. Alpha y equals fraction 1,000 tangent of 32. And then down here, it's tangent of 35, close parentheses, that's important, minus tangent of 32. This is x, leave it on my screen. And then y is equal to x times tangent of 35. So times tangent of 35. So for y, I get an approximation of 5,807.655. This is measured in feet because that 1,000 distance that was given in the problem was 1,000 feet closer. All right, last problem. Now this one, we can shorten this up a bit if we take a quick look at the picture. It says to measure the height of a cloud cover at an airport, a worker shines a spotlight upward at an angle of 75 degrees from the horizontal. So they're giving us the picture here. An observer 600 meters away finds an angle of elevation to be 45 degrees. Find h. So now here's the thing. normally I would say, okay, I don't know how to split up this 600. It doesn't look like it's 300, 300, right? It can't be because they're not looking up at the same angle. But if this is x, then this is whatever 600 minus x is. Meaning if x is 500, the remaining part is 100. But here's the other thing. X and H are equal to each other because look, this is a 45, 90, so it's got to be a 45, 45, 90. That's an isosceles triangle right there. So why is that important? Because we know that if we've been setting up two tangent equations, right? The tangent of 45 degrees would be equal to h over x, okay? And then this one would be the tangent of 75 degrees would be equal to h over 600 minus x. And I could go through this like I've been doing and figure out what h is, but I can also say, wait a minute, h is actually equal to x. So why don't I, in this equation, that doesn't help me. Tangent of 45 equals 1 over 1, or x over x doesn't give me anything to work with. But here, if I say, okay, that means that the tangent of 75 degrees, instead of h over 600 minus x, I can sub in x because h is equal to x. So that's nice because this gives me an equation that only has one variable and I can solve it. So I'm going to solve it by multiplying 600 minus x over to the other side. So 600 tangent of 75 minus x tangent of 75 equals just x is left over here. Same thing we've been doing. Get your x's on one side. So let's keep 600 tangent of 75 on the left side. And let's add the other x expression to the right side. So x plus x tangent of 75. We get our x's together so that we can factor an x out. So that leaves me with 1 plus tangent of 75 in the parentheses. And then I divide. So x is 600 tangent of 75 degrees divided by 1 plus tangent of 75 degrees. And just like we've been doing, that's x. Normally I'd have to go back and say, but what is h? But remember, x is equal to h. So whatever I get for this is my answer for h. So let's see. Get it into a fraction. Actually, let me do, if you're not putting things in a fraction, here's how you would type it in. Because I know not all of you can easily find that in your calculator, or you might not all have that in your calculator. It's the numerator divided by parentheses, the denominator. You need parentheses anytime you're doing addition or subtraction within a numerator or denominator. So I get 473.205, and that's measured in meters, because 600 was measured in meters. All right. So I know that the word right triangle trig, word problems in general, can be confusing, but what you should do as you're going through this packet is look for the patterns and rework the problems that all had, like these last handful of problems had the same math. So it's really about like, okay, when the triangle looks like this is how I set it up and these are the steps I took. Or when the triangle looks like this is how I set it up. These were the steps I took. So that's kind of how you study for these types of problems. I won't give you any new types of applications. So anything that you saw in this packet is fair game, but it'll just be different numbers.